Hello friends, in this video we will see how to convert a NFA into DFA. But before the conversion, let us take simple example of what is a NFA and what is a DFA. So NFA, it stands for Non-Deterministic Finite Automata. And DFA stands for Deterministic Finite Automata. Now what do we mean by deterministic and non-deterministic here? When we say deterministic, that means for a given input, there is only one transition defined for a given state. And non-deterministic means that for the same state and the same input, more than one transitions are defined. That is a non-deterministic machine. So with the same input string, we can generate multiple outputs for a non-deterministic finite automata. So let us take one example. Suppose there is a state Q0, there is a state Q1, and there is a state Q2. And let us say that Q2 is the accepting state and Q0 is the initial state. Now for an input of 0, there is a self loop in Q0. As soon as a 1 is identified, we move to Q1. As soon as the second 1 is identified, we move to Q0. And then there is a self loop for 0 and 1 here. And Q0 on the input of 1 can also move to Q2. And Q2 has a self transition for a 1 and it can go to Q1 for a 0. And let us say it also has a self transition for 0. Now here when we construct the transition table, we will have 3 states and 2 inputs defined with us. So we have the input 0 and input 1 and the set of states is there. So we have Q0, Q1 and Q2. Now Q0 on an input of 0 remains in Q0 and on an input of 1 it can move to Q1 also and it can move to Q2 also. So it is not a single state, but it is multiple states that can arise out of it. Similarly, Q1 on an input of 0, it remains in Q1. And on an input of 1, as we can see here, on an input of 1, it can remain in Q1 or it can go to Q0. So we have Q0 and Q1. So it is again more than one states which is possible. Then we have Q2. So Q2 on an input of 0, it can transition to Q1 or remain in Q2. So again we have 2 states, Q1, Q2 here, and on the input of 1, it will remain in Q2. So here we can see that for the same input, more than 2 states are defined. So this is the property of a NFA. In a DFA, this is not allowed. Only a single transition is possible for a given input and the state. So in the DFA and NFA, both have 5 tuples. So there is always a set of states Q. There is a input alphabet sigma. There is a transition function delta there is an initial state Q0 and there is a set of final states. But in case of a NFA, the transition function, it is defined as a mapping from Q cross the input alphabet into the power set of states. That means it can be a collection of multiple states. The output states can be multiple. But for a DFA, it is defined as, the transition is defined as just the input state into the input alphabet will give rise to just a single state from the set. Here it is the power set and here it is a single state. The initial state in a NFA is going to be a Q0 enclosed in square brackets, and here it is simply Q0. And here the set of final states is F, and here the set of final states will include a state Q which has an intersection with F is not phi. That means there is at least one final state in the Q. There is at least one final state and Q belongs to the power set of states. So what this means is that the final state is going to be a composite state which will include more than one states, and at least one of those states is going to be a final state. So this is the difference between a NFA and a DFA by definition. In the next video, we will see how to convert a NFA into a DFA. Thank you.